In this video, we're going to talk about supply and demand. So let's begin by defining demand. We say that, so let me underline this definition. So the demand, and the variable I'm going to use to denote demand is Q. So the demand of a commodity is the quantity of commodity that is desired. Okay, so I've deliberately sort of put the Q in quantity in a different color, and that's because one of the reasons why the variable for demand is Q is because the Q stands for quantity. So the Q stands for quantity. Okay, all right. So typically, when we write an equation for the demand, we will write the demand, and later when we talk about supply, we'll do this for supply as well, so and supply later, we will write demand as a function of price, of the price of the commodity. Okay, so price, the variable for that is P, the price of an item. So depending on what the price of an item is, the demand, like sort of the collective number of people that will want that commodity, will change. So typically, the higher the price of an item is, the lower the demand is, the less that people will want it. All right, so let's look at an example. So this is example 4, continuing the numbering of the examples from the previous videos of this section. So this says, suppose that Target sells 700 Nintendo Switches 1 month at a price of $300 per Switch. And the next month, Target increases the price by $50 and it sells 490 Switches. Suppose the demand is linear. So part A is asking us to find the demand function, and we'll call it Q of P. So Q, remember, is the variable that indicates demand, and it's a function of price. That's why P is written in the parentheses. And the second part of this is, what are the units? Okay, so the problem tells us that demand is linear. So somehow we need to convert the information that this tells us into points. So into some x comma y's. Except in our problem here, the variable that we're sort of plugging in, the x variable, is actually P. And instead of y, we have Q, and Q represents the demand. Okay, so the first sentence tells us that when the price is 300, so that's my first coordinate here. So when the price is 300, the quantity that Target sells is 700. It'll sell 700 Switches. There were 700 people who demanded a Switch. And when I say demanded there, I mean it's how many people actually went out and got a Switch, went out and paid for a Switch. Okay, so again, so the 300, that's the P value, that's the price. 700 is Q, that's the quantity, that's the demand. Okay, and there's one other piece of info. So the other piece of info is when they increase the price by 50, so that would be 300 plus 50, and that gives us 350. So when that's the new price, Target sold 490 Switches. So the demand there is 490. So that's our value of Q. Okay, so we have these 2 points, and we need to write down an equation of the line connecting these 2 points. So let's get the slope of that line. So I will do, so using our slope formula, 490 minus 700 over, so the difference in their P values, so 350 minus 300. Just got to stay consistent with the order. So on the top we have negative 210. On the bottom we have 50. And then I could divide top and bottom by 10 and get negative 21 over 5. And that's my slope right there. So now, in this problem, we don't know what the y-intercept is. So it's going to be easier for us to use point slope form. So let's use point slope form because we don't have the y-intercept, but we do have the slope and we do have a point. In fact, we have 2 points to choose from. So if we do point slope form, we would get y minus the y-coordinate of a point. So I'm going to pick, it doesn't really matter, I'm going to pick this point right here because the numbers just look a little bit nicer. They're just whole sort of hundreds. So the y-coordinate there is 700 equals the slope, which is negative 21 over 5, times x minus the x-coordinate of that point, which is 300. Okay, but of course, in my problem, we're actually not using the variables y and x. We're using q for the y. And what are we using for x? P for the x. So let's plug those in. So we get q minus 700 actually equals negative 21 over 5 times p minus 300. All right, so this problem said define the demand function. So that means, so the variable for demand is q. I need to isolate q. I need to get q by itself. Okay, so we have q minus 700. If we distribute negative 21 over 5 in, I get negative 21 over 5 times p. So I'm going to distribute it to both of these terms. So distributing it to that minus 300, we end up getting positive 1260. So, okay. All right, so now I just would need to add the 700 to isolate q. Q is negative 21 over 5 times p. And adding 700, we get 1960. Okay, so this is an equation for q. This is an equation for demand. This is the equation of the demand function. And then the question also wanted to know, what are the units? What are the units of demand here? So the units of demand, so the units of price are just dollars. The units of demand is whatever the unit is for the quantity of the item that we're talking about. And that's Nintendo Switches. So Nintendo Switches. Those are our units. All right, so now to get a feel for what this equation is saying, let's consider its graph. So let's draw the graph of our demand function. Okay, so I'm going to draw some axes. So we have a p-axis instead of an x-axis, and the y-axis is going to be represented by q. That's our demand. And the y-intercept is 1960. And the slope is negative. It's negative 21 over 5. So let's draw a line that has a negative slope. So it's going to be tending downwards like that as we go to the right. So I could plot these points that we had here. So we know, for example, that when the price is 300, that y value, or I guess I should say the q value, is 700. And when they increase the price to 350, so when they increase it to 350, so when p is 350, then q, the demand, was 490. So we have those 2 points on the graph. So the key thing that I want us to observe about this graph is notice that this graph is decreasing. It's decreasing, and intuitively the reason why it's decreasing is because as the price increases, which means as we're sort of going to the right in our graph, so that means the price is going up. The price of a Nintendo Switch that Target is charging is going up. As that happens, we would expect that less people will actually buy it. The demand decreases. So usually, this is the case in the real world. If the price of an item goes up, typically less people will go out and buy it. Because if it gets more expensive, they might think that it's not worth it anymore, or maybe it's outside of their budget. But usually for reasons like that, the demand decreases. All right, so let's keep going with this example. So that was just part A. Let's look at part B now. So part B is, well, if Target wants to sell 1,036 switches in 1 month, what should they charge for it? So in the original problem statement, it was already talking about the demand being in terms of 1 month. So the demand over 1 month. So we don't really need to worry about the fact that our time period here is 1 month. The problem was already assuming that the time period for demand was 1 month. Okay, so if Target wants to sell 1,036 switches, what that means is they need, sorry about that, not sure what happened there. They need to set the demand equal to 1,036. They need the demand to be 1,036. Okay, and we have an equation for the demand. It's negative 21 over 5p plus 1,960. So they need that to be equal to 1,036. If we rearrange this a little bit, if we move the 1,036 to the left, we will get 924. And moving negative 21 over 5p to the right, we get positive 21 over 5p. And then I could go ahead and multiply by the reciprocal, and I get p equals 924 times the reciprocal, which is 5 over 21. All right, and now I could cancel a little bit. It turns out that 21 goes in evenly into 924. It goes in 44 times. And if I multiply 44 times the 5, we get 220. So P, the price they should ask for, they should charge, is 220. The units are dollars. All right, so going back up to the graph, does that sort of make realistic sense? If they want to sell 1,036 switches, which is more than the 700, that would be somewhere up here, maybe somewhere up here. If they want to sell 1,036 switches, we would expect the price to be less. So the price there is 220. So that makes realistic sense. If they want to sell more switches, they need to charge less. And that's what we got. All right, so next let's define supply. So we've talked about demand a little bit. We've done a couple of examples. We're ready to define supply. Okay, so the supply and the variable that we actually use to denote supply is the same. It's also called Q. Okay, so let me keep going with the definition, and I'll come back and talk about that a little bit. So the supply, which we denote by the variable Q, of a commodity is the quantity that a producer or provider or firm or whoever is supplying this commodity makes available and puts out into the marketplace. So the reason, again, why, just similar to demand, why we're denoting this with a Q is because it refers to a quantity. It refers to a quantity, and I tried to put the Q of quantity in a different color to indicate that. So both supply and demand refer to quantities, and usually the convention is that we assign the variable Q to both of them. So it'll be clear from the context of a problem what the supply is and what the demand is. All right, so let's do some examples. So continuing the example that we had from above, let's just do a part C to this. So let's suppose that the supply function is Q of P equals P minus 40. Okay, so this problem tells us that this is the supply function. Okay, and we want to find the price at which the supply is going to be equal to the demand. So when the supply equals the demand, that has a special name. That is called equilibrium. So that is called equilibrium. And I'm going to highlight that. All right, so let's go ahead and highlight that. So that is a key word. So when the supply equals demand, we call that equilibrium. All right, so we want to set the supply equal to the demand. So let's write both. The supply is P minus 40. That equation is given to us. The demand we got in the earlier part of the problem. That was negative 21 over 5P plus 1,960. All right, so I just need to rearrange this to get the P isolated. So I'm going to move the negative 21 over 5P to the left-hand side. So when I do that, let's get a common denominator with this P. This P will become 5P over 5 if I multiply the top and the bottom by 5. And adding 21 over 5P to that, I would get 26 over 5 times P. And then if I add 40 to the right-hand side, 40 added to 1,960, that's 2,000. Okay, All right, so now let's isolate for the p. So I'll multiply by the reciprocal. So we get 2,000 times 5 over 26. And we can cancel this a little bit. 2,000 and 26 are both even, so we can divide them by 2, and I'll be left with 1,000 on top, 13 on bottom. And 13 doesn't go into 1,000, and it doesn't go into 5. So at this point, we can just multiply it out. The top is 5 times 1,000 is 5,000. On the bottom, we have 13. And this is a price, so the units of this are dollars. Okay, and that is what it wanted. It wanted the price at which this happens, and that's the price. If I wanted to put this in decimal form, I could use a calculator. And let me just go ahead and round this to 2 decimal places to get a feel for how much this is. This is about $384.62. So that's how much Target would need to charge for a Nintendo Switch if it wanted the supply to be equal to the demand. Okay. So the price at which equilibrium happens, we call that the equilibrium price. So the equilibrium price. And this is the price at which equilibrium occurs. It's the price at which the supply and the demand are equal. All right, so let me highlight that as well. Let's highlight this term, equilibrium price. So let's do another part to this example. In part D here, we want to find what's called the equilibrium demand. And that's the value of the demand. It's what the demand is at equilibrium. Okay, so at equilibrium, we know what P is. We found P already at equilibrium. It was 5,000 over 13. So if I know what P is, and I want to know what Q is, what the demand is, we can plug this in. We can plug this into the demand. But we have options. We could also plug it into the supply, because at equilibrium, these are the same. At equilibrium, I'm just going to abbreviate, at equal, these are the same. And by these, I mean the supply and the demand. So it shouldn't matter which one I'm plugging into, because they're supposed to be the same at this P value. Okay, so I'm actually going to go ahead and plug into the supply, because this supply equation was pretty simple. The supply equation was Q of P equals P minus 40. So if I plug in our value into that, so let's plug in 5,000 over 13 into this. We're going to plug that in for the P. We get 5,000 over 13 minus 40. And I have to simplify this, so let's get a common denominator. So this ends up being 5,000 over 13 minus, and then 40 gets multiplied by 13 over 13 to get a common denominator. Okay, and so we got 5,000. 40 times 13, that's 520, all over 13. And simplifying this, the numerator is 4,480. The denominator is 13. Okay, and what did this represent? This was representing Q. So Q represents a quantity, the quantity of the item that we're talking about. In this case, it was Nintendo Switches. Okay. So even though we plugged into the supply at equilibrium, the demand and the supply are exactly the same. That's why it was fine for us to plug into the supply in this special case. Okay, and to get a feel for what this number is, I've gone ahead and plugged this into a calculator. And if I round this to the nearest integer, we get 345. So for the supply to be equal to the demand, Target would need to be selling 345 switches. All right, so next I want to look at a graph of both the supply and the demand together to see what's going on at equilibrium in the graph, and then point out some key observations. All right, so let's draw a graph. So I'm going to draw some axes. Okay, so this is the p-axis, this is the q-axis, and I'm going to draw 2 graphs. So first I'm going to draw our demand graph that we had before. remember the y-intercept was 1960, and it was decreasing, it was going down like this. So this was our demand graph. And just as a reminder, the equation was Q equals negative 21/5p plus 1960. So that was its equation. And for supply, let me just write down what its equation was to remind myself. So supply was Q equals P minus 40. So P minus 40, which means the y-intercept here is going to be a negative number, actually. It's going to be negative 40. And then the slope is positive, so the graph is going to be going upwards like this. Okay, so that is our supply graph right there. So the place where these two graphs intersect, that is equilibrium. Equilibrium. So graphically, equilibrium is the intersection point of the supply and demand curves. And we found that the equilibrium price was 5,000/13. That was the equilibrium price. And the equilibrium demand, that would be on this other axis. We just figured that out literally right above this. This is right here. This was 4,480/13. That was the equilibrium demand. Okay, so two important things that I want to just point out about supply and demand here. So notice that supply is an increasing function here, and demand, we've talked about demand a little bit more in detail. Demand is decreasing, and we've talked about that before. So I'll explain why supply is increasing on a more logical level in just a minute or two. It's going to be one of the observations that I want to make. Okay, so I want to make some couple sort of observations about this graph and just kind of overarching observations about supply and demand. So the first is, in this graph, for a price that's greater than the equilibrium price, so greater than 5,000/13. So again, this is saying that when P is greater than the equilibrium price, so when the price is greater than the equilibrium price, in general, in terms of the graphs, the supply graph is greater than the demand graph. And we see that here. To the right of this equilibrium price, the supply graph is higher than the demand graph is. And when that happens, when there's more supply than there is demand, there is a surplus of the item. We end up with more of that item available in the marketplace than is actually bought by consumers. Okay, so this is called the surplus. On the flip side, for a price that is less than that equilibrium price, so less than 5,000/13. So in general, this is when P is less than the equilibrium price. Then it would be reversed. Then the supply is actually less than the demand. So there is more demand than there is supply. And when that happens, there is a shortage of the item. So two more observations. These ones are just more general observations about demand and supply and whether they're decreasing or increasing and why. So the demand we've seen is decreasing. Typically that's the case. And the reason why is since increasing the price, and that means as we move to the right in the graph, increasing the price usually leads to less people wanting to buy it. Typically, the pricier something gets, the less people who are willing to buy it. Supply, on the other hand, is an increasing graph, typically, since increasing the price, and that means whenever we're increasing the price, we're sort of moving to the right in the graph, increasing the price, usually, if we think about it from the supplier side or the provider or the producer, whoever's eventually going to be selling this item, usually when the price is higher, when they can price it higher, it incentivizes the producer to supply more of that item to the marketplace. Because if the price is higher, they'll earn more if they can produce more and then sell that quantity. So that's why supply is typically increasing. All right, so I want to end this video with an observation, just kind of like a note about how this appears in econ. So if you take an econ class, you'll learn about supply and demand as well. And one key difference about how it's presented in econ versus how we present it here in math classes is, in econ, the axes are usually switched. So they put the demand on this axis, and they put the price on this axis. So that is just a heads up. If you've seen this in econ, or you plan to take an econ class, in econ the convention is to switch the axes that these two variables are on.